Okay, we're going to go over optimization of exponential, and I just threw the word business functions, but it's essentially exponential functions. This one's dealing with a revenue, profit, and cost, okay, all involved in this. So, very large question. Let's try to read it and then go through the questions. A mathematical consultant, that's you, determines that the proportion of people who will have responded to the advertisement of a new product after it has been marketed for T days, so T representing days, is given by this function. Okay, so this function represents a proportion, and a proportion is essentially some form of a percentage. Okay, the area covered by the advertisement contains 10 million potential customers. Okay, that's good to know. And each responded to the advertisement results in a revenue to the company of 70 cents on average. Thank you for that. That's going to come into play on this question here. Excluding the cost of advertising, the advertising cost is $30,000 to produce and then $5,000 per day to run. That is a lot of information. Let's see what they really want from us in the first question, and then we'll go back and pick out the information that's important. Determine the limit at f of t when t is approaching infinity and interpret the results. So, f of t, so we're just focusing on the equation to start, and we're looking for the limit as t is approaching an infinite value. So the limit as t approaches infinity and is 0.7. Now, keep in mind, this 0.7, though it looks like it corresponds, is not involving this. This is not involved. This is finding out a proportion. This amount they earn is separate from that. So these two things are not the same thing. 1 minus e to the power of negative 2 t. Is that right? That's right. Okay. So we're looking for the limit as t approaches infinity. Okay. Well, we know that the limit, and if we recall from our limits, the limit of this value will be this value. The limit of 1 will be this value. We're going to focus on this as a limit in itself. Okay? So we're really going to be looking at the limit as t approaches infinity for the specific function of e to the power of negative 0.2 t. Okay? It doesn't look like this will be undefined, so let's plug in our value of an infinite for t. If we have e to the power of negative 0.2 times an infinite value, we'll essentially have e to the power of a negative infinite value as an exponent, which means as a positive exponent, we have 1 over e to a positive infinite value. Okay? And e to the power of infinity is an infinitely large number. So we have 1 over an infinitely large number, which essentially approximates to what? 1 divided by infinity. Anyone recall? Yeah, it's essentially 0. This number is so large on the bottom that it almost negates our 1. We're going with a value of roughly 0 here. So what that means is this part of our equation is essentially 0. And t being time, approaches infinity. So if this advertisement went on for the rest of time, we calculate that it would reach as a proportion, so think of it as a proportion of 1. We're subtracting 0 because that's 0, 0.7. So the idea of this would reach about 70% of the population if it went on forever. That's what this limit is talking about. Okay, so that's A. B. What percentage of potential customers have responded after 7 days of advertising? Okay, that's pretty straightforward. They want us to plug the value of 7 in for t and solve for our advertisement. So we use the original equation they gave us. Proportion. T at 7 in this case is equal to, I've already forgotten the equation, 0.7, 1 minus e, what is it? Negative 0.2. And we're replacing t with the value of 7. Okay. So we're essentially just working this out to find a proportion. This is our B in our question. I don't know if my calculator can do this. Can someone do the bracket for us here? Or at least the whole thing altogether? when we plug it in, I'll try it on the calculator here. E to the power of, that becomes negative 1.4. Okay, and then times 0.7. I don't think that worked out properly. Also, to subtract. Whoops, sorry. 1 subtract bracket e to the power of 1.4 when it's negative, end bracket equals times 0.7. What'd you get? Yes, that looks good. We got 0.52 something, maybe like 7. So approximately, if we're to put this as a percentage, this would round up. We're looking at approximately 53% of the population. So if you ran this advertisement for 7 days, we would reach roughly 53% of the population. Great. C. Write the function that represents the average profit. So this gets confusing. Oh, sorry, they've been writing this at F at T. I wrote it as P at T for a proportion or percentage. I'll change this letter for our sake. Write the function P at T that represents the average profit. So they need a profit function, T in days of advertising, and then what is the average profit after 7 days? So we have to make our function first. I'm just going to call it, what's we use for profit? Money. Money at time, okay? This is our profit. So the idea of profit deals with two things. Profit is your revenue minus your costs. Okay. So we are going to have to develop a formula for revenue, and then we'll have to develop a formula for costs and subtract the two values. Okay? So to start off, let's talk about our revenue. We have our original formula, which is 0.7 multiplied by 1 minus e to the power of negative 0.2t. Look, I memorized it by now. And they said our advertisement will reach 10 million people, which means this being a proportion, this representing a percentage, we will need to multiply this percentage by the population that it reaches. And because there's a population of 10 million, we need to multiply this value by 10 million. So I'm going to write in just 10 mil so it doesn't get too complex. Okay. So we have to multiply the size of our population by our percentage of the people this advertisement will reach. And that just gives us the number of people. From the people that are reached, it says we get a specific revenue in the question. If we jump up and take a look, it says that we get 70 cents on average for every person that's reached. Okay, so we might reach some people and they don't pay anything. We might reach other people and they pay a lot more. So what they're saying is on average, dude in green here, that's for money, it earns 7 cents for every person reached, not 770. So we need to multiply our 70 cents times our 10 million people times our percentage for our revenue function alone. Okay. So we're looking at, and I'll do these two parts here, 0.7 by 0.7. Turn that off. 0.49. And then 0.49 times 10 million. So times 0, 1, 2, 3, 4, 5, 6. What is that value? 4,900,000. So our revenue function is 4,900,000 times our percentage in terms of T. Okay. So this is our revenue function. That's only the revenue. We still have to get a cost function. Our cost function, what they said was this originally cost us $30,000 and then $5,000 per day to run. Well, this is a linear relationship. And what they're saying is right off the bat, we have to pay $30,000 for it, whether we don't run it at all. Even if we run it for 0 days, it costs us $30,000. But for every additional day, there's another cost of $5,000. You guys see the volume? Okay. So we have revenue and cost involved. So this is our profit function. We're going to put them all together. This means our profit in terms of t is equal to the revenue function, which is 4,900,000 times our percentage, which is 1 minus e to the power of negative 0.2t. Okay. And then we'll have to subtract our cost. So minus 30,000 plus 5,000 t. And we can distribute this negative. So all of our brackets can fall off. We're left with 4,900,000 times 1 minus e to the power of 2t minus 30,000 minus 5,000 t. This is our profit function. A bit complex to come to. And then they asked us, what was our average profit at 7 days? So they're asking us to plug in, for our profit, 7 days. So we need to replace the value of t with 7. So 4,900,000 times 1 minus e to the power of negative 0.2 times 7 minus 30,000 minus 5,000 times 7. Complex function right in. We can do this stuff. Our proportion here we know is actually around 53. Right? We calculate that already. So we have 4,900,000 times our approximate 53%, or in other words, 0.53, minus 30,000, minus 35,000. So we can do this all on a calculator here. I'm going to approximate 53, I know it won't be exact, times 4,900,000 minus, and that's going to be 65,000, equals 25,000. Nope, I hit the wrong number there. What did you guys get when you went through it? I put too many zeros involved. I said I made money. Yeah? Sorry, good point. We can't assume this is 53 because we already used up the 0.7 into our 4,900,000. So we can't make this assumption. So this is not 53, hence why I got a value that said we end up with more money than we should have. Does anyone know what it is in the end? This becomes 75%. Okay. So roughly 75%. Anybody want to try that as a final value? 0.75 times 3,610,000. Sounds right? All right. $3,610,000 at 7 days. That's pretty good. This company's doing all right. Okay, so at 7 days, this is their average profit. Not bad. We still have a final question. For how many full days should the advertising campaign run in order to maximize the average profit? So we have our profit function. That's very important now. Assuming the advertising budget is $200,000. So, first of all, that gives us a parameter for the number of days it can run. First of all, it can run for 0 days in terms of time. But because our profit function is 30,000, or sorry, our cost function minus, sorry, not minus, plus. And these values have to be less than or equal to the entire advertising budget. Our advertising budget is $200,000. Okay? So what we need to do is we need to figure out what the max number of days is for this to run. We can't spend more than $200,000 on this advertisement. So how long can we run this for? Which means we isolate T, and we end up with 5,000 T less than or equal to 170,000. Is that right? T less than, sorry, we divide these values. 34? Beautiful, thank you. Is 34. So the max number of days we can run this for is 34 days. Okay? So we have a minimum and a maximum number of days, but we got to find critical values in our profit function. So if we recall, our profit function is this lovely thing we did here. Now remember, this was 4 questions in one. This would be more along the lines of what you would do from here on. This is our profit function, so we need to derive this function with t being in the place of 7. I should have highlighted the one on top. Let's see if I can't copy it. I can. Wonderful. Let's jump to a new page just to make some room. Oh. There we go. So this is our profit function. To find critical values, we need to derive it. Okay? So we now have to derive this function. Okay? So we'll do this one step at a time because I went through it once, it didn't work out so nice. The very first part of this is product rule. Okay? So the derivative of our profit, this value becomes 0. So it becomes 0 times all of these numbers here. So 1 minus e, negative 2t. Okay? So we know this is going to cancel out. Then we're going to add, this is what we forgot last time, or I had. This value stays the same, which is 4,900,000, times the derivative of this part. Now this is the difficult thing to derive. Okay? So we're going to put it in red, and I'm going to derive it over here on the right. So in there it says 1 minus e to the negative 0.1t. Okay, so we go to derive this. The 1 derives into a value of 0. Okay? So the idea is this goes away. And we have negative e to the power of negative 0.2t. Think of this almost like a negative 1 value, you could say. When we go to derive this exponential function, specifically of e, we keep the original. So we have our negative e to the power of negative 0.2t. Okay. And then we derive what's up here. This derives into negative 0.2. So negative 0.2. So to simplify all of this, I can bring the negative 0.2 to the front. And because there's a negative here and a negative here, it becomes a positive. So we have positive 0.2 e to the power of negative 0.2t. So that is specifically the brackets. Okay, so that's this, the derivative of all this. Okay, so we're going to put this in, 0.2 e to the power of negative 0.2 t. So now we've taken care of our product rule. We've dealt with deriving these. The next one is 30,000, which derives to 0, so we can drop it off. And negative 5,000t derives to negative 5,000. Okay, kind of put this on the side. That was a side note we did. So now that we have that, let's simplify. The derivative of our money that had dropped off is equal to 4,900,000 times 0.2 e to the power of negative 0.2 t minus 5,000. Now this is where we need to, they said we want to maximize, so we have to set this equal to 0. And we could. We can move the 0.2 out to the 4.9 million. We could definitely do that. That would go right in. So let's do that. Make it even simpler. When we multiply that, what's it going to be like 9.8 with one less 0? Somebody just calculated there. I think it's 980,000 when we move it out. You guys just double check that for me, okay? And then the same idea, we're going to set it equal to 0. Okay? And the goal is to isolate for t. So I'm going to move 5,000 over, which becomes positive 5,000 on the other side is equal to 980,000 times e to the power of negative 0.2t. I want to move over the 980,000, so we get 5,000 divided by 980,000. Did anyone confirm if that's the right number? Yeah, it is? Good. Is equal to e to the power of negative 0.2t. Now this is a rule we do need to know, that ln e to the power of x is equal to just the exponent of x. So the natural logarithm of e is equal to our exponent of x. So that being the case, what we're going to do is take the ln of both sides. And the reason we're going to do this, we'll take the ln of this side, and we're going to take the ln of this side. And the reason we're going to do that is because on this side, the ln of e to this will just leave us with negative 0.2t. So we can now isolate for t. It makes it far simpler. On this side, though, we're going to have to plug this into a calculator. The ln of 5,000 divided by 980,000, which I will need your help for. negative 5.3. That's it? Okay. Which is equal to negative 0.2 t. So we bring over that negative 0.2, and it gives us a new t value of 26.4. 26.4. So in terms of time, because time's being measured in days, we'll, I guess, round down in this case, is approximately 26 days. So let's recap. We could run the ad for 0 days, for 26 days, or for 34 being our max. We got to put these values into the original to find which one maximizes our profit for us. So our profit function at the very beginning, which I think I wrote as, oh no, sorry. Profit function is what we started with. So this being our profit function, we've got to plug our values in for the t's and test them all out. So I'll rewrite the profit function down below. Money is equal to 490,000 times 1 minus e. I'm writing the right one, right? Yeah, 1 minus e to negative 2 t minus 30,000 minus 5,000 times t. So I'm going to write the values in. Can somebody please help us out and plug in? First, we'll do the first one at money at 0. Second one, money at 26 days. And the third one will be money at 34 days. So I'll write them out, what they look like, and you essentially give us a value. So we're going to replace the t's in both, which means we'll have 1. When I replace the t to 0 here, this will be 0. This will be 0. It's all going to be subtracted 1. This will all end up being 0. Oh, in fact, I can equate this myself. It looks like it's going to be negative 30,000. So this company loses money, which makes perfect sense. They said if they never run the ad, it costs them $30,000. So if they make it, it costs them $30,000. They don't run it for any days. They don't get any people buying into them. They lost $30,000. Makes perfect sense. Our second case, we plug in 1 minus e. Now here's a little more difficult. Yeah, 2 times 26. Okay, minus 30,000, and then minus 5,000 times 26. So I will give you hopefully a value of that in a second. And the last one I'll write out. Whenever you're ready, just tell me. 4,700,000. Perfect. $4,712,968. And in the second example, 34. So if they ran it for as long as they possibly could with their budget, it's 34. Our value at 34. So 4694, 542. Excellent. So they still make quite a bit of money, but they maximize their profit at running this ad for 26 days. Massive question.